All right. This is Chem 8 review on Lewis formulas, and it is a review intended because you are probably going to be questioned about this with free response questions on the common exam. All right, so diving right in, what we're going to be doing is writing or drawing structural diagrams for various compounds. So we're going to start with pH 3. Remember that the number one rule that most students avoid to their peril is not counting the total valence electrons to start. If you don't do that, I don't care about your memorization or what you think this or that, the structure is probably 99% of the time going to be wrong. So to count the total valence, we're going to start with the phosphorus. It is in group 5A. It has a total of 15 valence, it has a total of 5 valence electrons. And then we have 3 hydrogens for a total of 8. All right, so the next thing that we do is we draw the skeletal structure. And we put in the bonds to the external atoms. And then we do a quick count, and we see here we have 2, 4, 6. All right, and we're short 2 electrons. They go on the central atom in order to have a total of 8 electrons around the central atom. And then moving out, in this case, the external atom is hydrogen, and it can't ever hold more than 2 electrons. So this structure right here, most likely is the best option, and we do a quick test to make sure that we've used all of the valence electrons. So this guy up here, this is our magic number, what I call the magic number. So we count up, we've got 2, 4, 6, 8. This is most likely the best structure. All right, moving on. The next structure is going to be this particular molecule here. And if you haven't figured it out yet, right now what we're doing is we're moving down through a list of compounds on a homework assignment that was given to you guys on ChemDoctor several months ago. So again, if we're going to count up, carbon is out of group 4A, so there's 4 valence electrons here. We've got 1 atom from hydrogen, which is in group 1. And then we have 3 chlorines, which is out of group 7. So we have 21 electrons coming from the chlorines. Then we're going to have the singlet coming from the hydrogen. This is a total of 22. And then we have the 4 from and then we have the 4 electrons from the carbon. So this is a grand total of 26 electrons. All right, so now we need the skeletal structure. We're going to have H here. We're going to have a Cl here. We're going to have a Cl here, and we're going to have a Cl here. So when you do the skeletal structure, you write the central atom, and then you put the external atoms literally around it in a pattern which separates those atoms apart from one another as far apart as possible. Then, again, what we're going to do is just go in and we connect the external atoms to the central atom. All right, and then we place the remaining electrons on the external atoms. Remember, we cannot touch the hydrogen, cannot touch H, because it can't have more than 2 electrons next to it, and those 2 electrons are already here. So we're going to move over and we'll go ahead and place remaining electrons on the CLs. We're not counting right now. We're going to place those pairs so that there are literally 8 electrons around each CL, and we're not going to be concerned about the total number. We're just going to place pairs of electrons so there's a total of 8 is what we're going to do. Now, once we have the molecule completed, now we're going to do our test. So the first thing is, number 1 is to count the total electrons. And this number is going to have to match up with this one. All right, so we're going to have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. All right, so this number matches that number. The second test that we do is make sure that we're not violating the octet rule. And this is mainly going to apply to carbon, nitrogen, oxygen, and then the group 7 elements. All right, so looking at the carbon, we've got 2, 4, 6, 8. Looking at each of the CLs, we just reconfirm that there are 8 electrons around each one of them, and there are. So this structure is most likely the best structure. All right, moving on. The next option here is going to be SBr2. Sulfur is in group 6A, so we have 6 valence electrons, and then we have 2 atoms coming from group 7. So this is going to be equal to 6 plus 14. All right, so we have 14 plus 6, 6, 7, 8, 9, 10, and 1 over here for 20 total electrons. Next, we draw the skeletal structure. So we put S in the middle, and then we draw a BR to either side. Then we connect the central atom to the external atoms. Then we place electrons as pairs, starting on the central atom, so it has a total of 8 electrons, 2, 4, 6, 8. Then we move to the outer atoms, and out here I'm not going to count. All I'm going to do is add pairs to make sure I have 8. Get the job done, and then we do the test. Test number 1 is to count the total valence. This has to be done every single time. Every single time. We started out by counting the total here. Now we're going to recount that and make sure that we're matching. So on the central atom we have 2, 4, 6, 8. Then 10, 12, 14, 16, 18, 20. So we have 20 electrons here. All right, we have used the correct amount of valence electrons. The second test is to confirm the octet. And we see for that there are 8 electrons on the central atom, no problems there. We have 8 electrons around both external atoms, no problems there. So we have met both tests, and this structure is most probably the best one. All right, now the next option here is going to be CO2. All right, so the total valence, always counting the total valence, we're going to have 4 valence electrons for the carbons, and then oxygen is out of group 6A, so there's going to be 6 valence here, so we're going to have 12 plus 4 for a grand total of 16 total electrons. So now we're going to write the skeletal structure. Carbon goes in the middle. The oxygens are going to be external. Now for this one, what I'm going to do is demonstrate to you how the process works, because this molecule is not straightforward to the one that we did above. So what I'm going to do is show you how the process will lead you to the correct Lewis formula or structural formula. So I'm going to follow the rules, and I'm just going to go ahead and connect the central atom to the external atom. Then I'm going to come in and add pairs of electrons starting on the central atom so that there are 8, and then I'm going to move out. Again, what I'm doing right now is showing you how the list of rules, if you follow them, will lead you to the correct structure. Memorization is bad. Memorization is bad. Now, let's take a look at this, and we're going to run the tests. Test number 1 is to get the total valence. We know the magic number is 16 electrons. So I'm going to go ahead and count. We have 2, 4, 6, 8 on the carbon. Let's see. I would rather do it this other way. So we're going to have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 is the number we get. Now, we look at this number and we compare it to this number. And you can see that they are incorrect. They do not match. So what that tells you is that this structure is wrong. Now, the way that you get to the right structure, we see that the value that we got from this structure, which is wrong, was 20. And the number that we got over here is 16. The number that we have for the total valence is less than the number that we got from the structure that we drew to start with. The way that you get to a valence which is at a lesser number than where you ended up is by adding double bonds. So what we're going to do is redraw the structure. Here's my carbon, and I'm going to add a double bond here. I'm going to keep a single bond here, and I'm doing this to make a point. All right, and I'm going in now and I'm adding all of the number of electrons, so I have 8 around each of these. Notice that on the central carbon there's only 6, so I'll add a pair here. Now I go back and I'm going to retest. Let me just set the groundwork here. I need a number 2 there. All right, so I'm going to recount electrons. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18 now. Notice that we reduced the total number here, but it still does not match the total valence. This is the number that we have to match for this if you're using your brain. So I'm going to redraw the structure again. This time around, I'm adding 2 double bonds. Now you can see right away if we inspect the central carbon, there's 2, 4, 6, 8 electrons on it. So now we're going to add the electron pairs on the external atom so that there are 8. We have 2, 4, 6, 8. And then we're going to have 2 pairs over here. 2, 4, 6, 8. Now I'm going to go ahead and count the total valence. We have 2, 4, 6, 8, 10, 12, 14, 16 electrons. So now this number matches the total valence, and we know that this is now the correct structure. This is how it's done, not by memorization of structures. This is how it's done. So test number 1 was to count total valence. And that's how we ended up getting to the right structure. And then test number 2 is to make sure that we obey octet. That we obey the octet. And if you look down here, you can see that we did. The central carbon has 2, 4, 6, 8 around it. And each oxygen is 2, 4, 6, 8. 2, 4, 6, 8. So we've met both of the tests, and therefore the structure is correct. All right, we're going to go to one more window. All right, and what we're going to do for this one will be OF2. All right, and again, we're going to count total valence. Oxygen is coming out of group 6A, so there's 6 valence electrons, and we have 2 atoms out of group 7. So this is going to be 14 plus 6. 6, 7, 8, 9, 10. Carry the 1. So there are 20 electrons. This is the magic number. It's the number that we have to equal. All right, now I'm going to go in and I'm going to draw my skeletal structure. Here's my central atom. The external atoms are going to be the 2 fluorines. We're going to connect the dots. All right, and then we're going to add electrons without overthinking this. We need a total of 8 on the central atom, so I'm going to add 2 unshared pairs here. we've got 2, 4, 6, 8. The remaining pairs go on the F, so I'm not going to count electrons at this point. I'm going to put the pairs in. So there's a total of 8 on the external atoms. It's not rocket science. Now that I have all the electrons in place, now I'm going to do my testing. And test number 1 is to get the total valence again. So we're going to have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 electrons. And we see that this number matches that number. All right. Now, the second thing, before we start clapping our hands wildly and going, yay, 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 little Bobby, we need to look at whether or not we met the octet rule. So the central atom is 2, 4, 6, 8. Oxygen's good. The fluorine's 2, 4, 6, 8, and 2, 4, 6, 8. So we have met octet rule. This structure is dandy. All right, now let's see what we got on this list. We'll go to a charged molecule, so H3O plus. Again, nothing changes with this, but you need to remember for the charged molecules that for the anions, you're going to add the charge to valence count. And for the cations, you will subtract valence count. Okay, so let's check this out. Firstly, in the valence count, we're going to have hydrogen, which is a valence of 1. There are 3 of them. And then we're adding that to oxygen, which comes from group 6A, for a total of 6. All right, that's going to give us 9 for the total valence count, but we need to subtract the charge, which is 1. So the total number is 8 electrons. This is the magic number for this compound. All right, now, again, we draw the central atom and we put the external atoms around it. Then we connect central atom to external atoms. Then we place remaining electrons as pairs, starting on the central atom and moving out. Central atom, based on whether or not we've completed 8 electrons. So you can see we have 2, 4, 6, 8. And that happens to be the total number that exists for the magic number, so that we know that in test number 1 we have met the requirement. I'm just going to abbreviate that. And test number 2, we have to make sure we met the octet rule for oxygen. We see that we have, so we met octet. All right, and then for the hydrogens, they can never have more than 2. Never more than 2 electrons. Never more than 2 electrons. All right, with that, I'm going to go ahead and conclude the mini lesson.